And we are live
We're live.
already. So now we're chilling for the next 5 minutes while people join. And then, how was your week?
It was okay. Still adjusting to the new parent life. If I look a little tired, bags under my eyes, I don't know. I'm like looking at myself like, yeah,
No,
maybe I'm
you
a little
don't. You look
no.
younger.
Thanks, Vito.
Of
It's,
course, you're welcome.
being around so much youth is just bringing out the youth in me, I suppose. Yeah.
These
I was your
toddlers.
I
So we
was
have
I was your
Sylvie here.
Hey,
My
Sylvie.
week was great. My week was great. We have a lot of things coming. We have the ambassadors program kickoff next week. We have the guilds that are doing an amazing job. We just had a great sync with them. Hey, Abutika, welcome. And I'm sending also the reminders in the community. Just had an amazing sync with them. They're organizing great events, especially designer developers and technical writers guild. So if you are in the Alchemy University Discord, but you're not in a guild, you're missing so much. You should definitely join one. And also next week is the final week, isn't it? For the people that actually started when we launched.
Yeah, yeah, big news for you waiting at the end of week 7 content launch. You'll see that we're going to have a final project that we're going to release the details on January 19th. So you'll see once you get through all of the week 7 content that you have one final challenge there at the end. We'll be announcing the details of that next week. So super exciting.
Amazing. There's also Andreas from Colombia that has joined. I'm sending the message in the community. Andreas. And here's the link to the event. Maybe.
I'm excited for everybody in here who's up to date on the content. Week 7 is looking like a real exciting one for you guys. There's going to be You're going to be learning about contract upgradability. You're going to be learning about governance. You can actually the last task in the content this week is going to be running your own governance system. So if you've seen all these different protocols out on the ecosystem like Uniswap and Compound running their own proposals and actually executing on these proposals, you're going to be doing something very similar from the code and understanding how that whole process goes through. So super exciting stuff.
That's amazing. So yeah, what's the agenda today, Dan? What are we going to talk about is the release of the week 7. So I think there's a lot of things to learn.
Yeah. Absolutely. Yeah, there's so much to learn. Almost got ahead of myself a little bit. There's so much you need to learn in week 7 about this new type of message call that is going to be called delegate call. So delegate call opens up a whole bunch of new doors in Solidity. Up to this point, we have not touched on delegate call. Delegate call, what it allows you to do is say, I am going to hand off to another smart contract the ability to run on my code's execution or my execution context. So you can say to some other contract, execute on my storage, execute on my message contacts. So whoever my message value is, my message sender. This, of course, is a big security concern. And so if you actually start doing a lot your own, like looking into some of the security vulnerabilities that have happened in smart contracts over the last like 5-6 years, you're going to see that a lot of them have to do with delegate call because it's a tricky concept. But hopefully the way that we introduce it to you guys this week, it should be pretty fairly straightforward from what you've already learned from the call syntax. It's going to have a very similar syntax. You send the same exact type of call data through. The difference is going to be what you're handing off to the contract. And this allows you to do things like upgrading smart contracts. It allows you to do things like governance in many different ways. So yeah, really exciting stuff. Today, specifically, we're going to be talking about ERC20s because you just learned about them this week if you're keeping up with the content. So ERC20s, we just went over inheritance, we went over ERC20s, and we went over NFTs. There's a particularly confusing concept in ERC20s, which is called this dual flow, which is approve and then transfer from, and it trips up a lot of people. And so I want to showcase two things today. One is approve transfer from in a way where hopefully it's less confusing and it just sort of clicks for anyone who's watching. And then also, I want to show you guys not to be afraid of writing your own unit test cases. That's going to be, you're going to, if you really want to get good at Solidity smart contract writing, you need to get really good at writing unit test cases. And if you can get really good at unit test cases, you can challenge your own assumptions. You can build big smart contract systems and make sure that you have really, really good test coverage. And hopefully you'll have less bugs in your code that way. And your security auditors will thank you.
Well, that's amazing. Dan, I think we can get started now. Is 6 my time, 12 CST time, and probably 11 another time. And there are enough people here tuned in. I will start just launching the giveaway that we have every week during our town halls and during our weekly content kickoffs. Also, this is an amazing Alchemy hoodie.
Oh, no.
And yes, look at the hoodie. The hoodie is I cannot. I have too big of headphones. Um, so the thing that we're launching, look at Dan. So the thing that I wanted to launch is our giveaway. So you have the possibility to actually win. Me looking in the camera is completely different. Does it look like an interview?
Does it look like an interview?
Yeah, like an interview. I'm looking at the camera now and I'm
Yeah.
burning literally my eyes because I have so many lights in front of me. So while burning my eyes, I'm going to tell you, you can win some Alchemy swag. And to win some Alchemy swag, there is only two things that you need to do. The first thing that you need to do, thank you, Dan. I can just see you with like the corner of my eye. The first thing that you need to do is to take a screenshot of the content kickoff live. So on YouTube, you go on the page and you take a screenshot. Then you go on Twitter and or LinkedIn and you tag Alchemy University or Alchemy Learn. Alchemy Learn on Twitter, Alchemy University on LinkedIn. And you can tag also Bean, Dan Nolan, Vito Stack, or anyone that you want from the Alchemy fam. At the end of the session, we'll raffle 3 winners and announce them on Discord. So make sure to do it. Again, take a screenshot, post it on Twitter, tag Alchemy Learn, and you have the possibility to win Alchemy swag. Now, that said, I will stop talking and I will leave our magic, fabulous, gorgeous daddy Dan to present what we're going to learn the next week, and I think a short demo of what happened last week. So thank you, Dan. The floor is yours. Can you try to share your screen to see if
Yeah,
everything
absolutely.
works?
Let me do it.
I cannot see anything anymore. I am blind.
Here we go. Cool. Can you see my screen now?
I can add your screen. Yes, here we go.
Here we
Jam
go.
GDG.
All
The
right.
floor is yours. Thank you, Dan.
Okay, sweet. So what I'm going to do is I'm just going to start us off with a new repository, because I think that's just the easiest way for people to sort of follow along. So if you want to follow along now, or you want to follow along in the future, because this video is recorded and so you can go back to it, you can come back here and you can start with a brand new repository like I'm doing here. I tend to keep a folder on my desktop called temp repos. The reason I do it is just so that I remember to delete all these things later, because otherwise I just have like a million projects. And if you're like me, they all have like a ton of node modules inside of them. And then you end up with just like gigabytes and gigabytes of node modules like cluttering your system. So I start so many repos that I just call it temp repos. And this temp repo that we're going to be taking a look at is, let's call it like ERC20 advanced. What I want to talk about is ERC20, the approved transfer from flow. I want to try to build like an ERC20 from scratch. It won't exactly be compliant with the standard, but it's going to be something that's going to help us understand ERC20s a little bit better. And then I want to take a look at a vulnerability that occurred in a token that you all might have heard of at one point called Rune token, as well as something that Chainlink uses that is a really interesting part of the Chainlink token. So let's go ahead and dive in here. What I'm going to do is I start off with a new repository. I'm going to install Hardhat, and I'll zoom in for you all so you can see what I'm doing. So let's wait for Hardhat to install, and then we will go ahead and start us off with a new Hardhat project. All right, npx Hardhat, begin with the JavaScript project, and we'll jump in here. Okay, cool. So like always, hard hat kind of starts us off with a few things that we don't really need. We don't need this contract here. It's always nice to have this thing in here so you're reminded some of the syntax and you have some of the boilerplate code that you might need in your particular library. But for us, I'm just going to create something called a token. Maybe we'll use hard hat console log later, but we don't need it right now. This token is going to be a very basic token. It's not necessarily going to be EIP 20 compliant by the end of this stream, because really I just want to focus on a couple mechanisms, but hopefully, you know, it's only a couple steps away from being EIP compliant. So we will create this token. And then what I'm going to do is I'm going to delete the scripts folder, because the only thing we're going to focus on today is the test cases. And for my test cases, I'm just going to start off with token.js. I'm going to have this load fixture, because fixtures are really, really cool. They're a way that the Nomic Foundation Hard Hat has made it much, much easier to run performant test cases. So they are super, super cool. You can see they talk about fixtures here and being able to just reload, sort of snapshot the blockchain state and then reset back to that. So fixtures at first are a little bit confusing from somebody coming from any unit test casing background, and you're seeing fixtures for the first time, but just know that they're like a performance benefit. They make it so that you could easily just reload the blockchain state, so we can kind of like reuse a fixture each time. What I'm going to do is I'm going to call this my token, and I'm going to call this deploy token fixture. And for my deploy token fixture, I only need a couple things in here. Maybe we'll keep the owner. Yeah, we'll keep owner in the other account. That's helpful. And we'll have a token here. And we're going to deploy our token like this. And we will put it in here so that we can get it inside of our test cases, right? So we have our token, we have our owner, we have our other account. These are the three things that are going to get exposed. You don't necessarily have to return it in this way. You could return it like an array if you wanted to. You could return, you know, anything, any type of object that you can imagine, you could return it that way. It's just recommended to do it this way because when you go to load the fixture, you can kind of, pull it out in this way. It's really helpful. So like when we go to write a test case, right? I'll take this one, for example, and I'll delete all the other test cases because I won't really need too many here. You could say load fixture. You could put in the token fixture here, and then you could grab all three of these things, the token, the owner, and the other account like this, right? So because we returned it like an object, we can destructure it like an object, which just makes it really easy to sort of pull these things out. And the first thing that we really want to do is we just want to test that the token has a balance function. We're going to look up the balance of, let's say, token.balance of the owner address. And this should return us a balance of, I don't know, how much do we want to give the owner? Maybe we'll just say it should be greater than 0, right? So we should have like, I tend to use assert instead of expect, but you can go either way. I just really like assert for some reason. And I'm just going to say assert that balance is greater than 0. So that's what we're going to put in there. That's all I really care about here is that at the end of this, the owner's balance is greater than 0. We're just going to mint the owner some tokens, and that'll tell us right now that it should have minted the owner tokens. And also it'll tell us that we have built the balance of method properly. So this is what we're going to need to do. I'm going to run this test case just to show you what's going to go wrong here. Right now, we don't have a balance of method. So I think that's the first place where this is going to fail. But we might as well just run the test cases and see where we're at the moment. So we're running the test cases. There you go. Balance of is not a function. We need to go implement that balance of function on our token. So that's what we're going to do. We're going to do two things really here. We're going to create a constructor. Inside of our constructor, we're going to mint some tokens for the owner. So whoever deploys this token is going to get some tokens right in the beginning. You know, depending on how you're distributing your token, the token distribution might be a little bit different. For us, we're just going to distribute it straight to the owner here. So I'm going to have a mapping that is going to map an address to a bunch of balances. And then we're going to have a function called balance of. And this is something that you'll actually see on ERC20s, right? Which is a function that can take in an address for a user. And it's an external, it's a view function. Make sure to put view, because if you don't put view, Ethers.js is going to assume that this is a method that writes to the blockchain, in which case when you call this method with Ethers.js, it's going to treat it like a transaction. So you're going to pay gas for a method that doesn't even write to the blockchain. So you're going to be paying money for something that you ought not to be. So we're just going to say return to int here, and then we're going to return balances address like that, right? That's going to be our balances. And then if we want to pass that first test case, we just have to make sure that we mint some tokens to our owner. So
Interrupting super quickly, Dan, there is a question from Eduardo that is like, hi guys, do you think it could be helpful to follow this even if I'm not at this level yet?
I think so. Yeah, I'm trying to say it all at a level that hopefully is helpful for somebody even without too much Solidity background. And I'll try to keep it at that level. So thank you for the question. And I'll just try to keep it at that level and try to remember. But yeah, I think so. Hopefully it'll be helpful. And then the nice thing sometimes is like when you're watching streams that are a little bit more advanced from where you are, you see these concepts for the first time, and then when you go through the content, they start to really sink in. So I'd highly recommend that even if you have very little Solidity experience, to continue watching the stream and see how much you could follow, and then follow through with all the content and try to catch up. And yeah, hopefully this will be really helpful for you.
Amazing. Thank you, Dan.
Sure. Great. Cool. So one thing I'm not going to do with this token, just to make this a little bit simpler for our use cases, is I'm not going to use decimals. So decimals with ERC20 tokens, typically you can provide the level of precision that you want, because Solidity, historically has had it has no support for like floating point numbers. It does have like minimal fixed point numbers support. Basically what that means is we can't do stuff like 100.5 inside of Solidity. Instead, what we do is we use really, really big whole numbers. So like ether, for example, like ether, 1 ether is 10 to the 18th way, right? So like way is this really, really small amount of ether. So if you actually want to take a look at what 1 way is as when it's related to ether, it's like something like this, right? It's like really, really small unit of way. So what you could do is you can express everything in way, and that way you don't have to go to fractionals, right? So 1 ether, instead of being like this, is going to be this many way, right? If that's 18 zeros or 17 zeros or whatever it should be. So we express things in typically very, very big numbers. That way we have like the precision to go into like, the smaller fractions. For ERC20 tokens, they typically use the same amount of decimals, 18 decimals. I'm not going to do that here just because I want to keep this example really, really simple. But if you were going to build an EIP20 compliant token, you definitely would want to use decimals, and it's part of the standard. So I just want to make that distinction clear here. Not going to use it for the moment. We're just going to mint 10,000 tokens to the owner, and this should pass our test cases now, right? The one thing that's kind of interesting is I did use plus equals here. I didn't have to do plus equals here. The reason why I did plus equals here is I actually don't really know why, because it's going to start off at 0 anyway. Something that I really wanted to just point out with plus equals is that for mapping, all of these addresses are mapping to an unsigned integer. The unsigned integer at all these addresses is going to be a zeroed address. There's going to be nothing there. So that's going to be interpreted as for an unsigned integer is it's going to be interpreted as 0. So what this means on a high level is that everybody's balance is going to start off at 0. So regardless of whether I say plus equals or equals, the balances for the message sender on the constructor of the token is going to start off at 10,000, right? So we're going to give 10,000 tokens to our owner, which should pass our test case now, right? Because our test case is that we're deploying this token, and then we are just checking that the owner address has more than 0 tokens. They should have 10,000 tokens, right? So let's just make sure that this is working properly. We're going to say npx hard hat test. Looks like it's passing. Sometimes I want to test to make sure that everything is working the way I expect it to. So maybe we could even do like a balance is equal to 10,000 here, right? Something like that. So we could say it's greater than 0, it's equal to 10,000, that works. So if you guys are wondering where this GT and equals is coming from, like you may have not seen these before in JavaScript. JavaScript is not very good at handling very big numbers historically. Today, it actually does have like a big int type that you're going to see in most JavaScript, modern JavaScript engines. But historically, it was not very good at handling big numbers. So if you had like a number like this, you can see that JavaScript loses precision. It says e to the 32, and we actually lose the values after this point. So historically with JavaScript, when we're using big numbers, what we have to do is we have to include like a big number library. So ethers.js, when it returns you the balance of the owner here, it actually returns us as an ethers.js big number. So if I were to console.log that balance here, you're actually going to see this as an object. Didn't save it. If I save it, you're going to see it as a big number, right? This big number is something that Ethers.js provides in its documentation. So if you were to go look up Ethers.js big number, you're going to find the documentation for big number, which is going to include these methods like greater than and equal to. So when we want to compare big numbers to other big numbers or to regular numbers, we want to use these values here because we can't just do is equal to 0 like this, because then you're comparing an object to a number, and this is definitely going to return false. So just a little bit of a gotcha there to check out and to be aware of. Cool. So we minted our owner some tokens. So that's a very basic functionality of a token. We learned about mappings 2 weeks ago. So by this point, that should be fairly familiar to you all, or if you're just catching up, hopefully that's not too bad either, right? We're mapping an address over to an unsigned integer. This could represent every single address on the Ethereum blockchain. And then we could have a uint balance for all of those addresses, right? Cool. So the next piece of functionality.
Sorry, Dan.
Yeah.
I have another question from Sylvie that is asking if you can write in comment GT equals greater and EQ equals equal, please.
Yeah,
that
sure.
might not be. Thank you.
Yep. Yeah, absolutely. Cool.
And you have fans from Bhutan, by the way. There is
Nice.
Pema from Bhutan here that is saying, watching all the way from Bhutan. Hey, Pema.
Oh, cool. Okay. Glad to hear it. We're reaching wide and far today. Very cool. Awesome. So next part of what we're trying to do here is we just need to create a transfer method. So this one should also be pretty straightforward. You guys might have even implemented this yourself if you went through the week 6 content. We had a tutorial for building an ERC20 token, and you probably built the transfer method if you went through that content, right? So the transfer method, it's going to take, I always forget the order of the arguments, but I believe it is the address who we're sending it to, the recipient, and then the amount. But you know what? If you want to be EIP 20 compliant, then you may just want to look up EIP 20 and then find the method, right, transfer. So there's the address to and the uint value, so that's totally fine. So it's the recipient and the amount. We're going to make this external. And again, I'm not trying to be EIP 20 compliant, so this may not exactly match the spec. That's okay. Just doing this for learning purposes here today. I recommend that if you're going to launch an ERC20 token for some reason, you use the OpenZeppelin wizard. That's going to make it really, really easy for you to add custom features to your ERC20 token. And also you're going to be using an ERC20 token that has been audited by professionals, right? You don't want to release an ERC20 token that you yourself have come up with because even if you're a really good smart contract developer, you have to get that audited, right? If you want to keep any real funds in there. Otherwise, you could have all sorts of bugs. We've seen tons of bugs in the smart contract ecosystem, and these auditors know what to look for, right? So be really, really careful when you release stuff in the mainnet. Cool. So for this transfer method, what we want to do is we want to go ahead and move the funds over from the person calling the function to the recipient that's specified by this function, right? So really all we need to do there is just say balances recipient plus equals amount, balances message.sender minus equals amount. And that's really it, right? We could keep it that simple. For the EIP 20, like if you actually want to follow the standard, you would emit an event here And events are really good so that, you know, you could have servers that are crunching this data and turning it into a new database, making it really easy for you to view this data in the future. So you do want to follow the standard in most cases. In this case, I'm just trying to do this for learning purposes. This is all you really need in order to do the transfer method. One question, so there's actually there might be two questions here that people have. First of all, so let me pose these questions. One question would be, how do we know we have the authorization of the sender in this case, right? And the second question, which I'm going to pose, is what if the sender doesn't have enough tokens, right? Okay, so these are the two questions that I think you might come up with at this point, and they're both really good questions. One is, how do we know we have the authorization of the sender in this case? So with this function transfer, you'll notice we're not doing any sort of like security checks or anything like that. And so how do we know that the person who actually is sending the tokens is okay with it, right? Something that's really interesting when you're a smart contract developer is when the function is executing within the context of the message sender, you know you have their authorization because of public key cryptography, right? Public key cryptography is doing the heavy lifting here by actually having the message sender or the EOA at the beginning of the transaction sign a transaction saying, yes, I'm okay with sending this transaction, right? Or if this message was coming from another smart contract, that smart contract specifically coded that contract code to say, yes, I'm okay with calling this transfer method, right? So you can't spoof this message.sender, right? You can't like pretend to be Vito and then call the transfer method. Sorry, Vito, I said I wasn't going to pick on you this time. You can't pretend to be Cody and and pretend to be Cody and be the Cody message sender. You would actually have to either be the smart contract that's moving the funds or be the EOA, in which case you're signing the transaction from the get-go. So the reason why we know we have the authorization of the message sender is because it's either coming directly from the contract or coming from the EOA who has signed the transaction. So the second question is, what if the sender doesn't have enough tokens, right? Historically in Solidity, if the sender didn't have enough tokens, this line of code right here would be an issue because minus equals amount. Let's say the balance of the message sender, let's say that it was at like 10, right, before this line, and the amount that we were trying to send is 20, right? Previously in Solidity, if this was the case, what would happen is you would subtract 20 from 10, and this would actually overflow. It would actually, I think technically that's called an underflow, right? When you don't have enough room to fit it. It's going to actually go underneath the range and come out the other side of the range. So Solidity didn't previously handle this situation where you go below 0 in an unsigned integer, and this would actually flip to the other side of the range, and a uint can store up to 0x FFFFFFFFF for 32 Fs, 32 bytes worth of Fs. So we would actually flip over the range to a really, really big number, nearly the biggest number you could store in an unsigned integer. That would be a big problem. However, in Solidity 0.8 and above, what actually happens here in this case, where we had the balances is 10 and the amount is 20, is we actually get a revert here. This actually reverts the transaction so that nothing occurs. It reverts the entire transaction. All the state is rolled back. It's like this line never happened. We don't actually push any state changes to the Ethereum database, to the Ethereum world state. So if the sender doesn't have enough tokens in this case, because we're using Solidity version 0.8, we're actually in pretty good shape. So we can test that out, right? Let's just test two things. First of all, let's go over to the test cases, and it should allow us to send some tokens, right? Let's create a function here. I'm going to use arrow syntax. I'm used to it. And I'm going to pull this fixture down over here. I'm also going to have another account or the other accounts, right? And what I'm going to do is I'm going to say await token.transfer, and we're going to transfer to the other account, let's say 12,000, right? Because that's more than the owner has. The owner has 10,000. Let's just try to transfer 12,000 and see what happens. Now, one question you might have is, how do we, who is the message sender in this case, right? On this line right here, who is the message sender? By default, Hard Hat and Ethers is going to set this up for you so that this token that's being deployed in this line right here, this get contract factory, it's going to hook it up to the first signer. And the first signer in your signers is actually going to be this owner here. So this contract factory is already hooked up to the point where when this contract object comes in, whenever you call a method on this contract, the person paying for the gas, who is the original message sender, the original EOA, is always going to be this owner. If you wanted to change who the signer is, you can actually use this method called connect. And I could say connect to owner and transfer. This is redundant because it's already connected to the owner, but I could also say connect to other account and then transfer. If I tried to connect to the other account, that's not going to work, right? Because they don't have any tokens. So let's just go ahead and leave it as is and try to transfer 12,000 tokens. That's also not going to work because we only have 10,000 tokens, but I want to see what happens, right? Okay, we got some big ugly error, right? It said reverted with panic code 0x11, arithmetic operation underflowed or overflowed outside of an unchecked block. So that sounds really ugly, but it's telling us exactly what we expected to happen. And if we follow the stack trace right here, you can see it's pointing at token.sol line 18, and that is this line right here. We underflowed the balances mapping here by going below what the message sender had. So we don't actually have to encode a check here because Solidity is going to do this by default for us in Solidity version 0.8 and above. So we actually don't have to worry about that one in this case. And if you guys haven't gotten up to this point in the curriculum yet, one thing to note about reverts is that when you revert this line, it's like this line never happened. It reverts the entire transaction. The transaction is referred to as something like atomic, if you've heard this word before, which means it's all or nothing, right? If we're reverting the transaction, none of the state changes go through. So that's a really important concept. Cool, but we could transfer, maybe 2,000 to the other account. If we transfer 2,000 to the other account, then we expect a couple things to happen, right? We can take this code down here, which is going to look up the balance. We could say the balance of the owner, and then we could also do the balance of the other and look up the other account address. And what we should expect to see here is that the balance of the owner is going to be equal to 8,000, right? And then the balance of the other is going to be equal to 2,000, right? Because we started with 10,000, we transferred 2,000 over to the other account. So the balance of the owner is now 8,000, balance of the other, 2,000, right? So let's see if that works. Let's see if we have this transfer working. Cool, looks like it's working, right? So our certs are passing. We have 8,000 in the owner, 2,000 in the other. One thing to note about fixtures is that if I write another it down here, like if I were to do this, it should allow us to do approve transfer from. That's the next thing I'm going to want to do. I'll make that async. When I go to use this fixture down here, the fixture is going to actually reset the blockchain state back to the last time it ran the fixture. So it's when we run code down here like this, it's like this code never happened, right? So when we start a new test case down here, we can start it before we did this transfer from the owner, the 2,000 over. So in this case, when we get down here, the balance of the owner is actually going to be 10,000. And I'll just prove that to you real quick, because it's always good to prove it, right? Because I've been wrong in the past. We can say 10,000 down there. It's like every time we load the fixture, we're starting this off anew. So we can run that, and we should see that the owner now has 10,000, right? We're starting it all over again whenever we load the fixture. If we wanted to include, this transfer in the fixture, we could do that. So that way it's part of the fixture every time. But in this case, I'm totally fine resetting, starting anew each time as we go along. Cool. Awesome. Any questions came through, Vito?
No, we have comments. There is one question that is a little bit unrelated from Ali. How do we give value to a token? How do we decide this will cost $1 initially? I don't know if you want to answer this question right now.
Yeah. I mean, so the answer for that question is really just that's something that the market decides, right? A token has the value that anyone is willing to buy it for, right? So if you can find a buyer for a token that's willing to buy the token at $1 per the token, then you could technically say that that token is worth $1. Now, that's only true insofar as you can find many buyers that are willing to buy it at a certain price, right? If the volume isn't that high, then you don't really have a token price of $1. Like if I had 10,000 tokens and there's only one person in the world willing to buy one of those tokens for $1, then I could sell one of those tokens for $1 and then I'm still holding on to 9,999 tokens. It's not really worth $1, right? So there's kind of this complex dynamic that comes in when you start working with markets on how much a token is worth. So it's really like if you take a look at Uniswap, if you take a look at more centralized order books like Coinbase or like Gemini. I'm trying to think of a good example of a centralized order book exchange. If you look at these and you take a look at like who's willing to buy the token, that's what's going to determine the prices there. So our token, as far as the code we're writing in the smart contract code, has nothing to do with that, right? We write smart contract code, and then we could put it on a smart contract market like Uniswap, and then people are going to buy and sell that token, and that's what's going to decide the price of the token.
Yeah, I just want to add on top of that, but because this is actually a super interesting question, and Dan's answer was amazing. On top of that, I think if you have like 1,000 tokens and only one person buys one of your tokens for $1, then the value of your tokens is actually 1 divided by 999. And if you follow this rule, that is like standard economic rule of how inflation works, then if you want to give an actual value to a token, what you could actually do is create a liquidity pool on Uniswap and then bake your token with a certain amount of Ethereums. And then at that point, if you divide the amount of Ethereum by the amount of tokens you're actually baking with that Ethereum, you can tell that your token has that value because people will need to buy at that price. Now, this is very much not how standard currencies work. So everything is a little bit funky, as Dan said, because you can also do that and pour like 100 ETH into your liquidity pool with your token, but then just lose 100 ETH in like 0.2 seconds if there is no reason why people should pay that for the price, right? So it's very difficult to determine a price. It's more about marketing and adoption usually than, and of course, the product that that token is making. Anyway, on top of that, I think Ahmed here was at a certain point asking that it says a weird question. Maybe what happens if we cover the block with unchecked?
Yeah, so unchecked is going to actually make it so that we do have to go back to what we were doing before Solidity 0.8. So I was talking about this change in Solidity 0.7 and below. This is actually the behavior when you put an unchecked curly braces, when you create a block for unchecked. This is actually the behavior we got for Solidity 0.7 and before. Once we got to Solidity 0.8, the default behavior became that we actually do this overflow checking, that we get that panic code that we saw a moment ago. But before 0.7, we actually had this behavior of unchecked, where it wouldn't actually check to see whether or not we're going below 0. Something that you'll actually see oftentimes in smart contract or smart contract repositories where people know what they're doing. Sometimes they'll actually do unchecked because they know that they're not going to overflow and they want to save on gas because the Solidity is going to compile this down to opcodes and it's going to do a little extra work to actually check for things. So if you know what you're doing, you can actually put something in an unchecked block. But if you don't know what you're doing or you're not being extra careful, you could lead to an issue here, right? Because if we make this unchecked, we go back to this test case over here, right? And we say, we're going to send the other account 12,000. What do you guys think the balance of the owner is going to be in this case? It's going to be that flipped side of the range, right? I don't even know what that number is going to be, but it's going to be a really big number. If we look at the balance of the owner, because the owner starts with 10,000, and then if we try to transfer 12,000 over to the other account, it's going to go below 0, and it's going to flip the range. So let's see what the owner ends up being here in that case. This number. Yeah, that looks familiar, the 115. This is like close to the biggest unsigned integer you can store. So unsigned integer 256s can store numbers up to basically this big, which is a very, very huge number. Probably a number we never really have to use in any sort of finance. I'd imagine like it's a pretty large number. So the owner gave more money to somebody than they had, and then they ended up with a lot more money than they should ever have, right? Those are the dangers of using unchecked, or not doing checks in Solidity 07 or before. So in Solidity 07 and before, what you wanted to do is you wanted to say, check that the balances of the message sender is greater than or equal to the amount that they're trying to send. So at the very least, they can go down to 0, but they can't go below it. And then this would actually then run this revert here. And we could say, no, you don't have the money, man. Or, well, man, we'll do both. Yeah, you don't have the money. Yeah, see, it's giving me this revert right here, right? Passing in the reason string. So it's saying, no, you don't have the money, sorry. This is what we want to do here is we want to require it. If we were doing the unchecked behavior, or if we were doing this below 07. Yeah, it's a good question.
Was the whole man a prepared thing? Tell me yes. You didn't come up with it on the fly.
No, no, yeah, just
That's experience. Just listening to experience. On top of that, I would say these were all the questions. Then there is a question about the giveaway. Andreas, no, the giveaway is not only for people on Twitter, it's also for the people on LinkedIn in general. Twitter is the one that is most popular, but you can do it also on LinkedIn. And Amit is asking when the giveaway winners will be announced. That's a couple of hours after the session. Anyway, these were the questions. If you want to go forward, if there is anything else.
Okay, cool. We have 15 minutes left here before we hit the hour. So I'm just going to try to speed through as much of this as I can in the next 10 minutes, and then I'll take some questions at the end. So let's see how far we can get, because I do have a couple other things I wanted to cover here. So let's continue on here.
To everyone, just make sure if you have a question, now is the moment to ask them. And in 10 minutes, we'll go through an AMA answering all of your questions. Thank you so much.
Awesome. Cool. So if we had a contract, let's call it like, I don't know, Uniswap or something, right? This isn't really Uniswap, but if we had like a protocol, let's call it protocol, that wanted to receive some of our ERC20 tokens, how would we do it? And again, this is an ERC20 token, but it acts a lot like one. So it's very, very similar to an ERC20 token, and it could become one if we continue to integrate the ERC20 standard. If we wanted to send some tokens over to a protocol, protocol doesn't actually, so let's say the protocol is keeping track of the all of the tokens that have been sent to it, right? So this protocol has a function that says, so it has a bunch of balances, and it wants to know when you send it ERC20 tokens. So send ERC20 tokens, right? And when you send it ERC20 tokens, we'll send some amount. What it's going to do is it's going to keep track of who sent it the tokens, and it's going to say balances message sender is equal to the amount, or maybe plus equals the amount if they're adding more ERC20 tokens. What's the problem with this code right now? Right now, this protocol, the way it acts is all it's doing is it's asking you to send it an amount, and then it's just sort of adding that to the mapping here and trusting that you sent the ERC20 tokens over, right? You may not have sent the ERC20 tokens over. If we actually want to send ERC20 tokens to the protocol, what we have to do is we have to call transfer on the token, and we need to add the protocol as a recipient. Let's go ahead and do that just to see that example, right? Let's make this example back to what it was so that we just keep our code clean here. It was 2000, and then it should allow us to send tokens to the protocol address, to the protocol. And the protocol is going to be a new contract. The protocol is going to be a new contract, which we are going to go ahead and deploy, and we're going to store in our code here, and then pull it out down over here, right? We'll pull out the protocol. The protocol is going to be, it's going to have an address. If we actually want to send tokens over to a protocol, it's very much like the other account, right? We just do a transfer. We say token.transfer to protocol address, and then we're going to end up with this balance on the protocol address, where the protocol address has 2,000 tokens, much like our other account did, right? So we have the balance of the protocol, and we can see that the balance of proto is going to be equal to 2,000, right? So this is very similar to what we would do if we were sending it over to somebody else, some other account, some other EOA. We would just send them using the token transfer, and we would put 2,000 tokens into the protocol, and this works, right? We could just send 2,000 tokens over to the protocol just like that. The problem is here, the protocol has no idea it received 2,000 tokens, right? Because the protocol wasn't even invoked. The only thing that we called out to was this token to say token.transfer. So what actually executed here is we sent call data over to the token contract, and the token contract just updated this balances mapping where the recipient was the smart contract. It was the protocol address. But what we didn't call was we didn't call send ERC20 tokens. So we could do that, right? We could say, okay, await protocol.send ERC20 tokens. And then we could say we sent 2,000 tokens over and actually do that, right? So now the protocol knows that we gave it the 2,000 tokens. The problem is, what's stopping us from being like 12,000? I sent you over 16,000 tokens. I sent you over 76,000 tokens, right? I could tell the protocol I sent over as many tokens as I want, and the protocol has no way to really verify that. It has no way to know who sent it, what tokens, right? Because something that's not happening here during this transaction's execution on line 43 is the protocol is not getting invoked. So it has no way to actually do that balances update. And then when we go to run line 44, it can't attribute that new balance to anyone in particular. Now you might say, what if the protocol did something where when we send over 2,000, it does something like it could call out to the token, and it could say token.balance of, look at my balance and see if I have 2,000 new tokens. If it's equal to 2,000, or if it's equal to the amount, then we're going to go ahead and say that's attributed to the message sender, right? Something like this, right? Where we're calling out to the token and testing to see if we have that new balance. And maybe we could keep running track of whenever we have a new balance. But still here, we are trusting the message sender, right? Like if Cody deposited some funds and then I ran a transaction right after Cody, I could pretend to be the person that deposited those ERC20 tokens. The protocol is having to trust us, which is a problem, right? This is where the approved transfer from flow came in to solve this problem, because the protocol needs some way to be able to attribute who sent it the ERC20 tokens. It needs to be invoked in the actual transaction where the funds are being transferred over, right? So what we actually need to do is we need to introduce a new method on the token called approve. If you've used Uniswap, or you've used Aave, or you've used any of these like DeFi protocols, you probably have seen something where you have to do a two-step process where you have to approve a certain balance first and then do a transfer from. The way that this works is when you approve something, you approve somebody, some spender, some amount of your tokens. You say you're allowed to spend a certain amount of my tokens. And then what we're going to do is on the transfer from, somebody is going to come along and say, I want to spend this amount of the owner's tokens. So let's take a look at what that would look like. For the approved method, we're going to have a new mapping that is going to map somebody's address to the person who can spend it. So another mapping inside here to an unsigned integer. And this is going to be called our allowances. So what you can do is you can say, I'm going to allow Uniswap or a protocol to spend this amount of my token, right? And maybe we want to do like a plus equals here or something. We could say approve and then set a very specific amount here. So I'm going to say allowances. We have to keep track of the way we're doing this, right? The first address has to be me, the second address has to be the spender. So I'm going to say message.sender, spender is equal to amount. So now when I call this as me, I'm saying that the protocol can spend this amount. So on a transfer from, what we need to do is we need to say require that the allowances of the so the person calling this, in this case, transfer from, is going to be called from the protocol. So it may be a little bit easier to take a look at this from the outside, but we're going to have to check that the allowances of the owner to this message sender is greater than or equal to the amount here, right? Because we want to make sure that somebody has already allowed them to spend the tokens. So at the end of the day, the way that this works is in the protocol, you would, in the first transaction, you would approve the protocol to spend your tokens. And then from the protocol side, what you would do is you would say, protocol, we would have to actually get the address of the token. So we'd have to get the address of the token, and we'd say token transfer from the owner, which is going to be the message sender in this case, and then we're going to say the amount here. So we're going to say, I'm going to pull these tokens from your account into my balance, right? And we know if this transfer from succeeds because of this require, we know that we've received those funds. So the first thing it's going to do is it's going to check to make sure that the allowances are such that this person can actually spend the owner's funds. And then what it's going to do is it's going to subtract that from their allowances so they can't re-spend that token in the future. And then it's going to go ahead and do a transfer, right? Basically the same thing that we did here. It's going to add to the, in this case, it's going to add to the message sender's account, which is the person calling this contract, the protocol in this case. And then it's going to subtract from the owner's account. So it's actually going to pull those funds over. Now, what's the difference here? The big difference here is that now the protocol, when we actually go to do the balances update, it's going to pull those tokens in. So it knows on this line, I know that these tokens came from the message sender. If you take a look at this from the protocol, it becomes very clear why this makes sense, right? You're saying, I know that these tokens came from the message sender, so I can attribute this balance to the message sender because I'm actually being aware of the fact that this transfer from is coming over. So what we need to do with the approved transfer from is we need to basically give the execution control to the protocol to be able to then do this like calculation here, right? So this would be the approved transfer from flow. We may just want to test this real quick to make sure this is working, and then we can see if the balances has been updated, and then we'll take a question or two if there are any. So let's go ahead and just do that. Maybe there's a typo in here. We want to test that out real quick. So what we would do instead of token.transfer is we would say token.approve from the owner. We're going to say approve the protocol, which is going to be the spender in this case. We're going to approve the protocol to spend 2,000 of our tokens, right? And then the protocol is, we're going to say send ERC20 tokens in this case. Maybe we could call it deposit, right? I think that makes more sense. On the protocol, we're going to call protocol.deposit, passing in the token address, and then we are going to pass in the amount that we want to deposit, which is going to be 2,000 here, right? So this is going to be the 1-2 step, right? Approve. This is going to be the transfer from, and the transfer from where the balance is actually getting transferred is in the hands of the protocol, right? Now the protocol actually has the responsibility of pulling those tokens over, in which case it could know that it actually came from us. So the balances should be properly set up now, right? So hopefully these test cases still work. And there's one big thing that we're going to notice is a big change here. Let's just run those test cases to see if that's working properly. Okay, so this is still working properly with the approved transfer from, where we're moving the funds over to the protocol by having the protocol pull those funds through the transfer from. But there's one other thing that we get from this, which is now the protocol is tracking its own set of balances, right? So if this is like Uniswap, Vito was talking about this idea of a liquidity pool earlier. If this was Uniswap, Uniswap could actually track the fact that you are a liquidity provider. You are somebody who is willing to take the trade whenever somebody interacts with the Uniswap protocol and buys or sells the tokens, right? That's what it means to be a liquidity provider. And Uniswap needs to keep track of who the liquidity providers are so that way it can give back the funds to those people, or whatever funds happen to be in the pool at that time that is proportional to how much they deposited, right? So it's really important that protocols can keep their own internal state of balances, which is where this approved transfer from comes in. And if we test that real quick, we should have a balance in, let's call it balance in protocol, is going to be await protocol dot balance of, and the protocol is going to keep track of the balance of the owner, right? And this right here should be 2000, because it knows that the owner was the one who deposited 2000 in this case, and it can do that securely because of the approved transfer from flow. Balance of, sorry. What did I call this? Balances, sorry. So I made this a public balances mapping. So we can actually look up the balance by calling balances here on the mapping. We just have to pass in an address, and then it's going to return the value there, 2000. Cool. All right, and we are passing. There's two other things that we're not going to get to just because we're reaching the top of the hour, and I want to give some time for questions. Two things to research on your own. One is something called EIP 677. This is actually something that Chainlink uses, where they actually have a method where you can call something called transfer and call, and you can interact with the token directly, and then the token will call out to a smart contract. That changes the way that this works in such a way where you don't need this extra approve and then transfer from, which is an interesting like alteration to the typical flow here. And then there's one other thing that's also really interesting is look up something called the Rune coin exploit. The Rune coin did something really interesting where they decided we also don't want to do this approved transfer from flow. And what they decided is they were going to have a transfer where instead of using the message sender, they were going to use transaction origin here. Now, the difference between message sender and transaction origin is message sender is the last person to make the call. So a message call. So in the case of message sender, if you're an EOA calling contract A, calling contract B, for contract B, the message sender is going to be contract A, as long as this is a regular message call. If you're talking about this flow with transaction origin, then in contract B, the EOA is a transaction origin. So transaction origin means the EOA. There's always an EOA at the beginning of every transaction because contracts can't start the transaction. So the transaction origin is always going to be the EOA. The problem with this right here, I wonder if anyone could see the problem. You'll find this if you look up the post-mortem to the Rune exploit. It's like a phishing exploit, because if you could get somebody to call your contract, let's say you have a malicious contract, that malicious contract can call into transfer and pull the Rune coins from you because you are the transaction origin in that case, and we haven't technically gotten your approval. So you want to avoid using transaction origin in this case. That's just something to watch out from. I would take a look, if you're interested, take a look at the post-mortem on that to see exactly what went wrong. And as a challenge for you guys, I would also suggest trying out to actually doing that exploit yourself. See if you could use a malicious contract that manages to pull funds from somebody using the transaction origin here instead of the message sender. That'll really challenge like your understanding of this, which will be really helpful here. Cool. That is it. Did we get any questions on any of the code, Vito?
Oh, I was muted. Not really. It looks like Space Falcon thought it was really, really helpful. Sylvie might have had hard times following everything, but I think just because it was packed with information, so it was amazing. I learned a lot. Rohit was also super stoked about it. So not really questions, just a lot of compliments and people liking the session. Well done, Dan.
Awesome. Glad to hear it. Okay, I will stop streaming then.
Alrighty. So, quick reminder that next week will be the week where A will launch the ambassadors program. B, there is the final projects, and it's going to be 3 weeks of building projects. Make sure to join the guild. 3 weeks, not only for today. 3 weeks of building projects. So make sure to join a guild, find your teammates, and build with everyone else in Alchemy University in the Alchemy Learn Discord. GDG will be there helping you out. The GDG is our amazing ambassadors coordinator. Robinson saying thanks for sharing. I will watch the replay again. And thanks, Dan. It was amazing as always by Abutika. I hope I'm spelling your name right. On top of that, we will announce the winners of the giveaway in 2 hours on Discord. So keep an eye on the town hall. We will tag the winners 2 hours, not free, not one, but two. And so sorry for today for the people that actually joined on GMT. I know that on Twitter a couple of days ago, I've been announced that it was on 6 p.m. GMT. I am 6 CST, and this is like a public I don't know, like I'm saying publicly that I scheduled for 6 p.m. CST and not UTC. So we were like 1 hour early. Oh my God. But the recording is here so everyone can catch up. And we have made the announcements all over. So make sure to catch up with the amazing dance session. Dan, anything else you want to say to our amazing students?
No, enjoy the governance stuff, guys. I guess that's the only thing. The content is now live for week 7. I hope you guys really enjoy it. I think this is one of the most interesting weeks. And if you really like this stuff, then you're going to love just getting into Solidity even more. So check it out. Super excited.
Amazing. All right. Thank you so much, everyone. Make sure smart contract security dedicated live. That would be amazing. We're planning to have a ton of lives in the next few weeks. Now, not because all the content has been released, we stopped doing lives. That's actually not the case. We have a lot planned. We have a lot of other protocols and companies that want to come and talk about what they're doing, what they're developing, and how you can develop using their tools. But on top of that, we also have internally a bunch of live sessions that we want to have with you. So stay tuned. And again, if you have doubts on the kind of events that we're having for that precise week, just go on Discord in the event section and you will see all the right times actually.
Vito has so many lives scheduled that if you killed him, he would just come back because he's got so many lives.
I don't think so. Please don't kill me. It's not true. If you kill me, I die, like everyone.
Don't kill Vito. Don't kill Vito.
Please. All right. Thank you, everyone. Thank you so much, Dan, once again. And talk to you later on Discord.
See you, everybody. Thanks for
See
tuning
you.
in.